questions 11 through 20 on the 2019 Grade 8 AMC 8. The 8th grade class at Lincoln Middle School has 93 students. Each student takes a math class or a foreign language class or both. There are 70 8th graders taking math, 54 taking language. How many 8th graders take only a math class and not a foreign language class? Well, these are one of those famous Venn diagrams, and don't get intimidated. I will explain. So this first circle represents, in our question, the math, all the students that take the math. The second circle represents all the students that take a foreign language. And then, of course, there's an overlap because some take both. And each of these regions I will label either A, B, or C. So based on the question, A plus B plus C, the total is 93. And then A plus B, the students that take math, they are saying is 70. And B plus C, the students that take a language, is 54. So the question essentially is asking me to find A, which is how many 8th graders take only math. Okay, so we have to solve the system of equations, so that's not a big deal. Let's just use this one. A plus B, well, B from here is 70 minus A. And then C from here is 54 minus B. Like that. And that equals 93. So let's see, well, the A's cancel. So that leaves me with 70 plus 54 minus B is equal to 93. Well, B is 70 minus A, so let's substitute that in. So 70 minus A, so it actually becomes plus A when you take it out of the bracket. So this is what we're left with. These 70s cancel, so A will be 93 minus 54, which is 39. So number 11, the answer is D. The faces of a cube are painted in 6 different colors: red, white, green, brown, aqua, and purple. The 3 views of the cube are shown below. What is the color of the face opposite the aqua face? There's a really nice way of looking at cubes, and I'll draw it for you. And basically it is as follows. You are separating the cube into sort of a flat surface like this, and that will give you a relatively decent idea of how the letters or the colors are going to be placed. So let's just concentrate first on the RG, because I see an RW here, so it looks like that's a continuum. W, then R, then G. So W, then R, then G. I'm pretty confident, since they're going to be in a row like that, that they can belong there. Now what's above the R? In both scenarios, it's B, so B goes there. And then what else have we been shown here? It looks like P is below the R, and G is to the right of the R. So P goes here. The only letter I haven't placed is aqua, so aqua goes here. Now in your mind, close this shape, make it into a cube, and when you do, what would be opposite the aqua? Well, if this is the top, aqua would be the bottom face. So opposite the aqua is R, which is red. So number 12, the answer is A. A palindrome is a number that has the same value when read from left to right or from right to left. For example, 1, 2, 3, 2, 1 is a palindrome. Let n be the least 3-digit integer which is not a palindrome, but which is the sum of 3 distinct 2-digit palindromes. What is the sum of the digits of n? So we want the least. All right, let's start talking about the palindromes that are 2-digit. 1, 1, 2, 2, 3, 3, and so on. And we want to add 3 of these guys. All right, so 3 of them, but I want the least. So let's try these 3 first. And when you do, you get 6, 6. Well, that's bad for 2 reasons. First of all, it's not a 3-digit integer, and it is a palindrome because they want something that's not a palindrome. Okay, so that didn't work. No problem. Let's keep going. I'm going to keep the 1, 1 and the 2, 2. But let's see what happens if I add something else. If I keep going here, the first time I actually get something that is above a 2-digit number is when I add 77. Because if I added 66, it would go up to 99. So I have to add 77 in order to make it a 3-digit integer. And when I do, that 3-digit integer is 110. So let's see. That's satisfied and not a palindrome. Correct, it's not a palindrome. And I'm pretty confident this is n. So the sum of the digits of 110 is 1 plus 1 plus 0, which is 2. So number 13, the answer is A. Isabella has 6 coupons that can be redeemed for free ice cream cones at Pete's Sweet Treats. In order to make the coupons last, she decides that she will redeem one every 10 days until she has used them all. She knows that Pete's is closed on Sundays, but as she circles the 6 dates on her calendar, she realizes that no circled date falls on a Sunday. On what day of the week does Isabella redeem her first coupon? So what we can do is make a mini calendar, Sunday, Monday, and so on. And then we have to basically not select a Sunday since the ice cream place is closed on that day. All right, so let's just start with the first of the month and let's fill this out. All right, so here we go. Now we want to choose 6 dates, right? But we can never choose a date on a Sunday because the place is closed. And also, the dates have to be 10 days apart. So you do some experimentation. Let's start with 2. 10 days apart would be 2, 12, 22. Whoa, 22 is there. Can't use that. Let's start with 3. 10 days would be 3, 13, 23, 33, 43, but there's a 43 there. So can't do that. Let's start with here. It would be 4, 14, 24, 34, 44, 54, and none of those are in the Sunday column. 4, 14, 24, 34, 44, and 54. Is that 6 dates? 1, 2, 3, 4, 5, 6. Yeah. So I can do it like that without hitting a Sunday and use the coupons, whatever. So it looks like, what are they asking? When does she start? Well, she started on a Wednesday. So number 14, the answer is C. On a beach, 50 people are wearing sunglasses and 35 people are wearing caps. Some people are wearing both sunglasses and caps. If one of the people wearing a cap is selected at random, the probability that this person is also wearing sunglasses is 2 over 5. If instead someone wearing sunglasses is selected at random, what is the probability that this person is also wearing a cap? All right. Once again, we've got these cool Venn diagrams, and let's see what we get. So again, this circle will be the sunglass circle, and this one will be the cap circle. So I'll label the regions A, B, C. Okay. So the question basically tells me that A plus B is 50. And B plus C is 35. Now let's take into consideration this sentence here. If one of the people wearing a cap is selected at random, the probability that this person is also wearing sunglasses is 2 over 5. All right, so how do I take that information, put it into an equation? Basically, it means that of these guys, if you take B, B is also wearing a sunglass, right? Because B is that common region. So that sentence can be written mathematically as B over B plus C is equal to 2 over 5. So that's going to help me solve for the next part of the question. So let's cross multiply. 5B is equal to 2B plus 2C. So that means 3B is equal to 2C. And therefore, well, whatever way you want to do this, 3B over 2 is equal to C. Okay. That will help me solve for B in that equation. So that means B plus C is 35. So C is 3B over 2 is 35. Multiply through by 2. You got 2B plus 3B is equal to 70. And 5B is 70. And therefore B is 14. So if B is 14, then C I can easily get just by subtracting from 35. So C would be 35 minus 14. So C is 21. And I can also get A by using that equation. So A is going to be 50 minus B, which is 14. So A is equal to 36. Okay. Now finally, if instead someone wearing sunglasses is selected at random, what is the probability that this person is also wearing a cap? So mathematically what that means is they want you to figure out this one, B over A plus B. That's what that sentence means. So B we calculated to be 14, A plus B is 50, so 14 over 50. And in lowest terms that would be 7 over 25. So number 15, the answer is B. Kiang drives 15 miles at an average speed of 30 miles per hour. How many additional miles will he have to drive at 55 miles per hour to average 50 miles per hour for the entire trip? Well, as always, speed is equal to distance over time. And time is equal to distance over speed, whichever way you want to do this. So for the first part, time, the distance is 15 miles and the speed is 30 miles per hour. So that time is 0.5 hours. Now they have this scenario that they're saying, how many additional miles will he have to drive at 55 miles per hour to average 50 miles per hour? So now we'll use this formula. We want that to be 50. And the distance, well, the first segment was 15 miles. The second segment, they don't tell us, so I'll just call it X. That's actually what we have to find out. And then the time, for the first one, we just figured out it was 0.5. And for the second segment, the time, I have to figure out a formula independently. The distance over speed. The distance is X, and the speed is 55. So that's what I put here, X over 55. So here's my equation. So cross multiply, and you got 25 plus 50 over 55 is 10 over 11 x, and that's 15 plus x. And then 10 would be x over 11, and then cross multiply, and you get 110 for x. So that's the answer. Number 16, the choice D would be the correct answer. What is the value of this product? All right. I am going to write out a few more. Probably helps just to write out a few more. I don't think you'll need that many. Just following the same pattern. So I think I'll go a few more. Just 5 times 5, 6 times 6. I think that's good enough. So 1, 2, 3, 4, 5, 3, 4, 5, 6, 7. Okay. In a very similar way, I'll write out the other end, and I'll add like a few more. Maybe I'll add like 3 more. So now let's figure out what happens. A lot of stuff will cancel. This 2 cancels there. 3's cancel. 4's cancel. 5 cancel. 3's cancel here. 4's cancel there. 5 cancels there. 6 cancels there. And as you can see, all of these guys will eventually just cancel out. Now let's look at the other end. 98 cancels here. 97 cancels there. 96 with there. These 95s cancel. These 94s cancel. Let's go the other direction. 95s cancel. 96 cancel. 97, 98, 99. So as you can see, all of these guys are gone if you continue the pattern. So the only thing that's left is this 1, this 2, and at the very end, this 100 and this 99. So that becomes just 50 over 99. So very interesting. Number 17, the answer is B. The faces on each of 2 fair dice are numbered 1, 2, 3, 5, 7, 8. When 2 dice are tossed, what is the probability that their sum will be an even number? All right, so this is a 6 by 6 scenario. And since that isn't that many, I'm just going to write them all out. So for example, if we had the first dice roll a 1, the second dice could be 1, 2, 3, 5, 7, 8, and so on, right? So I'm just going to write out, there's only 36 combinations and won't take that much time. All right, now that they're all written out, all we really have to do is just look at the ones that have a sum that's even. All right, let's circle those. These guys, these 4. Next one, these 2. And then 3, 1, that's 4, and so on. So just go through it and it won't be that difficult to circle the ones that have a sum that is even. Let's see here, an 8, 2, and an 8, 8. There you go. So how many did I circle? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 of the total was 36. So divide top and bottom by 4, and that would give me 5 over 9. So number 18, the answer is C. In a tournament, there are 6 teams that play each other twice. A team earns 3 points for a win, 1 point for a draw, and 0 points for a loss. After all the games have been played, it turns out that the top 3 teams earn the same number of total points. What is the greatest possible number of total points for each of the top 3 teams? Well, let's label the teams A, B, C, D, E, F. And we've got wins, we've got ties, and we've got losses. All right, well, we want 3 of the teams to be tied, right, at the end with regard to points. So I'll put the points down here. Okay, so how can I do this? Well, let's think of scenarios here. Let's think of a scenario first when they have the same number of wins and then they have the same number of ties, let's say. Okay, well, they each play each other team twice. So there's 6 teams. Each is going to play the other 5 twice. So each plays 10 games. So let's make it simple so that each of these teams beats these teams. So the top 3 teams are A, B, C, and A beats D, E, and F all the time. So they play, A beats D twice because they played twice, and then plays E twice, and then plays F twice. So there's 6 games that A plays against D, E, and F, right? A, D twice, A against E twice, and A against F twice. And let's say that A wins all of those 6 games, so win is 6. In a very similar way, B plays D, B plays E, and B plays F all twice. So B beats all of those teams. And same thing with C, that C also wins when C plays D, E, and F. Okay, so now we've got 6, 6, 6. Now we're talking about the tie situation. In the tie situation, let's say they tie against each other. So, for example, when A plays B, they tie. And they play twice, so they tie twice. When A plays C, they tie. They play twice, they tie twice. And then B plays C, they tie, and they tie twice. So each team looks like ties 4 times, right? Because A ties twice with B and twice with C. So that's 4 ties, and for each tie, they get 1 point. So the total points would be 6 times 3, because you get 3 for a win, and then 4 times 1. So that's what, 18 plus 4, which is 22. So the points total will be 22, and the losses are 0 here. So 22 is one of the answers, but let's see if we can get something bigger if we use a different scenario. And that scenario this time being a scenario with losses instead of ties. All right, so let's get rid of these ties, and I'll keep the points in there. So I'll just label this. This was the tie scenario. Okay, now let's talk about losses. If you've got losses, then 6 teams have already 6 games have already been played, right? And that's what those represent. So we've got 4 more games to account for. So in order to get equal, I'm going to assign 2 more wins to each of these guys, and then 2 losses here. So that would make it 8 and 2. And then there's no ties. And then over here, since we have a total, looks like 8 times 3, so that's 24 wins. So there has to be 24 losses. And we've got 6 here, so 24 minus 6 is 18. And then 18 divided by 3 is 8. So that means these guys have to have 8 losses each. There's no ties that we're talking about, so the wins, there's got to be 2, 2, 2, because that column has to add up to 10 since there's 10 games. All right, let's figure out the points here. This time is 8 wins, and then no ties, and losses you don't get any points. So that looks like 24. So 24, 24, 24, and 24 is indeed higher than 22. So that is the greatest possible number of total points. It takes a little bit of fiddling around. Number 19, the answer therefore is C. How many different real numbers x satisfy the equation x squared minus 5 squared is equal to 16? Well, take the square root of both sides, and when you do, you get x squared minus 5 is equal to plus or minus 4. So that means x squared minus 5 is equal to 4, or x squared minus 5 is equal to negative 4. From the first one, we get x squared is equal to 9. From the second one, you get x squared is equal to 1. Now again, take the square root of both sides, and you get plus or minus 3. Here, you get plus or minus 1. So my values for x are 3, negative 3, 1, and negative 1. And as you can clearly see, that's 4 values. So number 20, the answer is D.